So now that we have looked at power a little bit, what do we understand of this? Well, we understand that it's an interesting interrelationship between alpha, beta, and sample size. So by and large, the larger the sample size, the smaller we can make alpha and beta. It reminds us a lot of when we did diagnostic testing with sensitivity and specificity. But here we've got this third entity, namely the sample size, and can we choose that to give us the desired power profile that we're looking for? So there is a very useful program in Stata. It's called, there it is, click on it, power and sample size. Let's look at the first one, tests of means and proportions, and we see we've got 4 options. Let's start with the second one, which is the one sample comparison of mean to hypothesized value. Now, what it wants from us is the hypothesized value and the standard deviation. And where do you want to calculate the power? That's the postulated. So let's put this aside for 1 second and let's see now. You remember we defined Todt-Scholl? We defined Todt-Scholl to be the difference between the cholesterol level at visit 2 minus the cholesterol level at visit 1. And so we had this variable Todt-Scholl, and so let's summarize it and to remind us what we had before, and there it is. So remember we said, oh, the mean was 13 and the standard deviation was 33. Now let's bring back our SAMC, it's called. There it is, SAMC. Let's bring that back. Now, let's see. What is the standard deviation? Let's go with the standard deviation of 33.3. 33.3. Now, let's hypothesize, as we did before, that the difference is 0. So that's our null hypothesis, that the difference is 0 between Todt-Scholl 2 and Todt-Scholl 1. Now, let's put a postulated one. So let's say something like 13. All right? So what this is setting us up for is the following. If we want to test the hypothesis that the difference is 0, the one sample, the difference is 0, what happens if in fact the difference is 13? Now we come with the options. All right, what alpha do we want? Let's put our friend 0.05 in for alpha, and now it suggests the power of the test to be 90%, and let's look at a two-sided test. And so what we're going to ask Stata to do for us is to compute the sample size. So what are we asking it to do? We're saying, well, how big a sample do I need if I'm going to test at the alpha equals 0.05 to have a 90% chance of detecting what? A difference of 13. So let's submit that, and there it is. So now what Stata says to us is, if you want to test the hypothesis that the difference is 0 in your one sample, remember this is the dependent case on the two samples, so that's the same as the one sample. So if we want to test the hypothesis that the mean difference is 0, or the mean is 0, with an alpha of 0.05 and a power of 90%, when the alternative is 13. See, these two link together. Where do you want the power? Remember the power curve? Where do you want the power curve to be 90%? And the answer is, well, the way we've set it up is at 13. When the standard deviation is 33, then it comes back and says you need a sample size 69. Okay? Now, we could have done it the other way. We could have said, all right, compute the power. Then it says, well, what is your sample size? Well, let's say our sample size is 69. Where do you want the power computed? And the answer is, we want the power computed at this postulated value of 13. And I hope now that when we submit this, we'll get back our 90%. And the answer is yes, there it is. We get 90.02%. Closer than that we couldn't get. Now, we have here a program that allows us all sorts of options. We can lower, instead of making an alpha of 0.05, we can make it higher, 0.1. What happens if we make this 0.1? How much power would we have then? We can do a one-sided or a two-sided test. What does that do to the power? Or if we click on sample size, what does that do to sample size? So I'm going to leave you now and let you experiment and explore this program a little bit on your own. And then when we come back, we'll do the 2 sample one. So for now, you go off and get an understanding of the 1 sample one.